Well, friends, we made it. We made it through Star Wars Day. Hope everybody had a good May the 4th. It was with them. And now it's time for the revenge of the 5th. It's Friday. Got to get down on Friday. As you can see, I'm out again today. You know, I got things I need to do in addition to doing this, so I can do both by filming the Bellringer ahead of time. That's how that works. Let's do it.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn on time. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
We've spent a little bit of time looking at how to count population, right? Populations. So populations are a group of all the same kind of thing living in a habitat, right? And populations are like the fundamental unit of ecology. We study how populations interact with other populations in the community and how the abiotic factors affect populations in the ecosystem, right? Of course, you know that populations are all the same species. And what's the definition for species again? That's right, you got this. We've done it a million times. Right? All the given members of the same species living in a given area is a population. And we figured out, we learned two ways to count them, right? By sampling and by doing what's called a mark and recapture. One of the things that's interesting about populations is that they grow, right? If you have more births than deaths, they grow. Populations tend to grow exponentially. Right? Here's an example of exponential population growth, a graph, right? Over time, population size gets bigger and bigger and bigger and bigger and bigger. It's like a log scale instead of just a regular flat line growth. Okay? The problem with that is habitat can only support so many individuals. All right? So there has to be a limit. And we call that limit the K line, or the carrying capacity. The carrying capacity is the limit. Right? How much an environment can, I think of it like a garbage bag, right? Like you could shove a whole bunch of garbage into a garbage bag, but there's only so much it can actually hold, right? If you try to shove, I mean, you could even shove more in it and more in it and more in it, but if you get to a point where it can't hold anymore, the bag's just gonna break. That's like a habitat, an ecosystem with populations. You can only hold so many before the population breaks. And then there's massive die-offs and massive deaths, right? So we think this carrying capacity is kind of this imaginary line that, now you can go above the carrying capacity, but better believe that once you go above the carrying capacity, you're gonna break the bag and population is gonna go down. Hopefully it doesn't totally wipe out the bag. Usually what happens is there's an undulation, a curve that goes above and below the carrying capacity in a population over time. Below a graph of typical population graph, right? Exponential growth, exceed the carrying capacity, then there's a lot of that, because competition for resources. You can't, there's a lot of starvation. There's not as many, it's competition for mates, competition for food, for water, for shelter. There's a big die-off, and then as soon as the number dips below the carrying capacity, now there's all this room again. So the population goes back up, and then it dips and goes up and down, up and down. We see that all the time with populations, that they don't really remain stagnant. They fluctuate around this line of the carrying capacity. So what limits a population? What keeps a population from exploding and reaching that carrying capacity? Well, it's because we have what are called limiting factors. Limiting factors are things that affect the ability, like, for example, food availability is a limiting factor, right? If there's not enough food available, there's going to be mass starvation, right? For animals here in like northern New York, accidents, getting hit by cars for deer, those kinds of things. Loss of habitat due to human development, building new homes, or forest fires, or, right? All these things affect populations. And of course, the fact that no animal lives forever, so eventually old age catches up with them, and that kills off some members of the population. And of course, their diseases and parasites are not unique to human beings, but all organisms have to deal with disease, which can limit the population. So we call these limiting factors. All right, so limiting factors for populations are those things in the environment that cause numbers to go down. Right, they're what counter the birth rate, and that's how we can maintain this kind of steady, fluctuating carrying capacity line of a population in a habitat. So as soon as you're done with this Bellringer, you've got an Ed puzzle to watch some amoeba sisters about biological levels of organization. You know, we're studying ecology. And then I have a worksheet for you for classwork today. We're going to work with a couple of population graphs. You're going to analyze those graphs. So the other day we made graphs. This time you're going to analyze those graphs. And then if you have lab today, or even if you don't, I'll remind you that the human population mini lab is due today. Likewise, your spirit animal is due today. And if you have lab today, I've got a video for you to watch on endangered species. Okay? Endangered species are those where the death rate is outperforming the birth rate, and they're going extinct. Have a great Friday. Have a great weekend. I put the Friday song in the stream so that you can play it. Please do, and enjoy.